All right, so let's go over the quiz you just took. So, x to the, what do you think? Fifth power, yes. Here we have x to the sixth power. So that right there is, when you see a problem when you're starting out, that's like where we form the rules. So one thing that I recommend on the test, if you forget the rules, is go back to a simpler problem. If you forget the laws of exponents, you can always expand, right? And see, okay, here's x to the third times itself, and that gives me x 3 times. So that can help you later on with your harder problems. Here, this would be x to the 12th, y to the 18th over z to the third. Since none of them have the same basis, we can't simplify anything. Here, though, this is the same thing. We were talking about simplifying. X to the fourth divided by x would be x to the what? Third. We subtract the exponents. What's y to the sixth divided by y to the sixth? 1. So you just wouldn't even put that in there. If you subtract the exponents, you get y to the 0. And remember that y to the 0 is equal to 1. Anything times 1 is itself. So if you have times 1, you would just get x to the third here. Over 1 is fine. Yeah, I mean, there's a lot of implied things going on. There's a coefficient of 1. There's a denominator of 1. If you write those in, that's not wrong. It's just you usually don't see them. Okay, here we have more x's in the denominator than we do in the numerator. So if we use that rule about subtracting, we would have x to the negative 1, which is the same thing as 1 over x. Remember that the sign of the exponent has nothing to do with the sign of the number, right? So because it's a negative exponent, it just means take the reciprocal. If you wrote out 9 x's and 10 x's, 9 of them would cancel, leaving 1 left in the denominator because you have more in the denominator. And remember, we always want to have positive exponents in our final answer. Okay, here what I would do is I would simplify. Remember we were talking about the upstairs neighbors, the downstairs neighbors? Well, apparently the roof is leaking upstairs, and so this x is very unhappy about it. They want to move out. But downstairs, x to the sixth is just fine. So if we move, because it has a negative exponent, we move this downstairs, who's living upstairs now? 1. 1 x to the 10th. Good. Okay, for scientific notation, we want to move the decimal. It's currently located here. We want to move it so that we have 1 digit. We want 7.63. We want to have 1 digit in front of the decimal. So I'm going to move it 3, 6, 9, 10, 11 times 10 to the 11th. Does that make sense? Here, I want to move the decimal to between the 4 and the 5. So I'm going to have 4.5 times 10. Now, since I'm moving it, since the number is very small, this exponent is going to be negative. I'm going to move it 1, 2, 3, 4, 5, 6 places. And it has to be negative 6 because the number itself is really, really small. A positive exponent tells me my number is really big, 4.5. This decimal moves 1, 2, 3, 4. The places where I don't have numbers get zeros. So that's 45,000, right? Here, this negative exponent tells me my number is really, really small. So 6.2, I'm going to move the decimal over 1, 2, 3. I like it if we put a 0 in front of the decimal. So I always think about it like this. If I'm going to move it, I'm going to put in 3 zeros, and I'm going to put the decimal in between the first and the second. Because this number tells me I want 3 zeros in front of the 6, but that's because I want a 0 in front of the decimal. It's better. Just looks better. Okay. On the back page, we're adding and subtracting. We're thinking about like terms. So our x to the third power, oh, you're right. X to the third power has opposite coefficients. These are like terms. and they actually cancel out. So I have no more x to the third powers, because if I have -7 of them plus +7 of them, they're gone. And then I'm looking for the next exponent is x squared. I don't see any other x squared, so that's going to be my leading coefficient is x squared. Then I have an x, and here's another x, -3x, +2x, -x, and -12 and -10 gives me -22. On the next one, I have to make sure that I distribute the negative sign. So I'll just make it easier if I change this to positive. Everything after it, the sign is opposite. And you can rewrite that if you want. So now I have a -7x to the third and a -7x to the third. And that gives me -14x to the third. I have no other x squareds, but because my sign changed, I now have a -x squared. And then here I have a +2x, I have a +3x, that adds to a 5x, and I have a -12 and a +10, that leaves me with -2. Okay, here I'm going to be multiplying, so I'm distributing. Now remember, when we multiply, that's the only time our exponents are going to change, is actually when we multiply, and today we're going to be doing division. So when we multiply or divide, our exponents change. 2 times 7 is 14. X to the third times x to the third is x to the 6. 2 times 1 is 2. X to the third times x squared is x to the 5th. 2 times -3 is -6. X to the third times x is x to the 4th. 2 times -10 is -20. X to the third, because there was no x's there. Equal sign. Equal sign. Equal sign. Okay? I'm going to do this one down below. We're going to FOIL. X times x is x squared. X times 6 is 6x. Inside, 5x, last, plus 30. X squared, I have like terms, plus 11x plus 30. Yeah?
So on A, is
Yes?
the 2x times 7x is not 14x to the 9th?
No, because here x to the third times x to the third,
But the parentheses don't change the rule?
because it's not to the power of, right? The parentheses in this case are not an exponent. The parentheses are indicating multiplication. So if I write this like this, x to the third times x to the third, that's the same multiplication, right? It's not taking it to another power. So in that case, we would have x to the 6. Yep. That's law. And you can go back to this one, laws of exponents. So that you see that difference is that's power to a power. Right. This one is you're multiplying to the same base. Okay.